Hello, pirates. Today's topic is the nitrogen cycle. And what you guys want to do, hopefully, you read the nitrogen cycle play because we're just going to kind of go through the processes that happened in the nitrogen cycle play so that you guys can understand how nitrogen cycles through ecosystems. With the nitrogen cycle, just like the carbon cycles in and out of living things into the non-living components of the atmosphere, and the same thing with the water cycle. So today we're going to look at how nitrogen, which is key and important, it is a building block, it is an element that is present in the nucleic acids, and it's present in proteins. So it's really important for structures and genetic information that this is cycling in and out of living things. It's a nutrient. So in your play, you had a tree. And if you read the play, there was also a little character, a little monkey. So here is Mr. Monkey right here. And there was a river nearby. There it is. And for Mr. Monkey, I'm going to give Mr. Monkey hands. I already made his arms look kind of funky, so he looks kind of like a weird spider or something. But sorry, Mr. Monkey. Here are his little monkey hands. And then over here, he'll have his little monkey feet. All right. So where we find nitrogen in the nitrogen cycle, just like we had carbon dioxide in the atmosphere, nitrogen is also present in the atmosphere. So in the atmosphere, we have atmospheric N2. So it exists as two nitrogen atoms together. So we have atmospheric nitrogen. And atmospheric nitrogen, kind of like carbon dioxide, diffuse back and forth between the ocean. Nitrogen diffuses back and forth in and out of the soil. So we have nitrogen gas that is being released into the atmosphere from the soil and then diffusing back into the soil. So soil plays a role in our nitrogen cycle. So here we have the soil. In the soil, there are bacteria. Okay, so in the soil, there are bacteria. These bacteria work kind of like decomposers. They're kind of like the living part of the soil. And what these little bacteria do is they take the nitrogen that's diffused into the soil and they take it through a process called nitrogen fixation. So the bacteria is going to go through a process called nitrogen fixation. And in this process, it's going to change the molecule of nitrogen. So the nitrogen is going to be turned into a nitrogen attached to another nitrogen compound that might have like oxygen in it. So it goes through nitrogen fixation. And this happens because it's what the bacteria do, but we can't use the nitrogen in the form of N2. So it has to be turned into this different type of nitrogen. So it turns into a usable form of nitrogen. So it's in a molecule that cells can now use. And what's going to happen with that usable form of nitrogen is it's going to get absorbed by plants. All right, so here we go back into the food chain. And the nutrients are going to get used to provide the nutrients the plant needs to make the molecules, to make the structural components, structures in the plant. With this nitrogen, this fertilizer, it becomes part of, the plant. And when we eat the plants, the nitrogen that's in the plants is going to be passed through the food chain from the nitrogen into the organism. So just like we would eat carbon compounds and get carbon, the same thing happens here. So the little monkey might eat the fruit, in this case, like a little fig on the fig tree. So it gets consumed. And now, eventually, the monkey is going to utilize the components of the fruit, and some things aren't going to get used, and those things are going to be released from the body as waste. So over here, the monkey is going to have some solid waste. I know, everybody's favorite is drawing monkey poop. All right, so here we have little monkey waste. And now this nitrogen is going to get back into the soil so it can get absorbed into the soil. Or what you guys saw happen in the play is the waste became runoff. Okay, so a rainstorm came. And with the rainstorm washed the monkey waste into the river. And now once it gets into the river, now that nitrogen is there to become a fertilizer for the plants in the river. So that nitrogen will also make its way into aquatic ecosystems. Now, when you guys read about eutrophication, you're going to read about how that nitrogen can also cause the algae to grow really well and eventually form an algal bloom. So we need, just the right amount of nitrogen in the water. Too much, and we get an algal bloom. Too little, and the plants can't grow. So we need a good balance. And that's kind of how aquatic ecosystems are. Aquatic ecosystems, I would say they have Goldilocks syndrome. Everything needs to be just right. All right. So what happens in an algal bloom is the algae grow really quickly. And with the algae, they are going to grow really quickly. They're going to block out the sun, and then they are going to decompose and die. And when they decompose, this high amounts of algae at the bottom of the river or the lake or the pond or the ocean, what happens is the bacteria use up the oxygen really quickly because they're going through so much respiration, breaking down the algae and dead things. And then when it takes all the oxygen out of the water, unfortunately, the fish and other aquatic organisms die because of the low O2. So you can read about that in a little bit. With this nitrogen cycle then, like I said, what you want to look at is you guys want to look at what are those human impacts. Okay, so what are the human impacts on the nitrogen cycle? And then you want to look at what are our solutions. So you guys want to pause this video, read the article on eutrophication that looks like this, and then you guys want to come back and look at those human impacts. So pause, read, fill out human impacts in the article, and then come back. All right, so with those human impacts, one of the things you guys should have picked up in the article was we impact the nitrogen cycle with agriculture runoff. So we have agriculture runoff, has high nitrogen in it. Population growth. More people means more agriculture needs, more waste, and all of it ends up in the waterways. Sometimes this leads to untreated wastewater. And this is more common in developing countries than countries that are already developed because they just don't have the infrastructure for proper sewage treatment. We also impact this through industrial runoff or air pollution. And the overall burning of fossil fuels. The big impact then is all of these things can lead to eutrophication. So eutrophication means that there are too many nutrients in the water. So eutrophication, too many nutrients. And when there's too many nutrients in the water, this can cause the algae to bloom. So we can end up with an algal bloom. And the algal bloom will eventually lead to a dead zone. So like we said, as the algae grows and dies, the decomposers break it down, and then we end up with low oxygen in the water, and that is going to be harmful to consumer populations like fish. Solutions. We could return the natural flow of water. So water flows through an ecosystem and the plants take it up. So we need like a natural water flow. Things like those bioswales. We need to reduce industrial waste. Air pollution, runoff. We need to reduce fossil fuels. We need to update and improve sewage treatment so that we aren't leaking raw sewage or not fully treated sewage water into the oceans or wastewater. We need to reduce the overall use of fertilizers. So we need less fertilizer being used overall. And another thing that we can do is we can pass laws. So one of these important things is that we can improve the regulations of wastewater and what goes into our environment. For example, when it comes to water, the Clean Water Act was huge in cleaning up the water in the United States. So laws can help. And we didn't use that for the water cycle or the carbon cycle, but we certainly could pass better laws or regulate. All right, so what you guys want to do then is you want to read about eutrophication. You guys have that little diagram that shows you the order of the steps. So nutrients load up, the plants flourish, the pollutants cause the aquatic plant growth. The algal blooms and the oxygen is depleted, preventing sunlight from reaching the plants. The plants die, and the oxygen in the water is depleted as the decomposers break down the plants. So the algae blooms, blocking out the sun, killing the plants decompose, the decomposers use up the oxygen. Decomposition further depletes the oxygen, and dead plants are broken down by bacteria, using up even more oxygen. Ultimately, we have the death of an ecosystem as the oxygen levels reach a point where life is no longer possible. All right, the last thing you guys want to do, the what am I submitting today, is you guys are going to write a paragraph. And so you guys are going to write a paragraph about eutrophication, and this is going to go in your notebooks on page 148. And on page 148, you guys are going to write a paragraph, so 5 to 6 sentences explaining the causes and effects of excess nitrogen and phosphorus in the Florida waterways. What do you think are the most important solutions to prevent eutrophication in our water? So what do we need to be doing in Florida to make sure that we do not have eutrophication events? And you guys can kind of look, I don't know if you've been watching the things with Piney Point, but you can kind of see how people are really concerned about the water that was released at Piney Point because it's from a fertilizer plant. And so that water is high in nutrients. Reach out if you guys have any questions. Have a wonderful day.